Okay, folks, so the second part of 3.2 is to bring some more algebra expressions here and solve some a little bit more complicated equations, and then also see some different looks of where you'll see these parallel lines in different shapes and figures, while still solving for values of angles or even values of variables. So up at the top here in this example, we want to take a look at what we're given. We're given angle 1. Okay, we're told that that's 3x plus 15. We're also given angle 2. That's 4x minus 5. I want to notice that these are parallel lines, P and Q. So 1 and 2 are corresponding, which means they're equal. So I can set those two expressions equal to each other. All right, so for angle 1 and angle 2, 3x plus 15, 4x minus 5, they're going to be equal. And then we're just solving an algebra equation. And then what happens next, we get x equals 20. Well, we're going to need that x equals 20 for the next part because we have to find y. And they told us that angle 3 is 5y. Well, again, if I look at these parallel lines here, I can see that angle 2 and angle 3 must be equal because they're corresponding. But if I use angle 2, the way they give it to me, 4x minus 5, I really won't be able to solve the equation. So I need to come over here and see, since I know that x is 20, then what I really have here is 4 times 20 minus 5, right? That's 4x minus 5, and x is 20. So 80 minus 5 is really going to be 75. And that's how we solve that. We have 75 equals 5y, and pretty simple solve from there. So let me zoom in on some of these examples, and we'll get a little bit more practice. So there's going to be 2 layers to this. I need to solve for both variables, x and y. So I see I have my parallel lines here. Okay, this is a triangle, but we have a parallel line cut through, so it actually forms what's called a trapezoid. We'll study those later when we have 2 bases that are parallel. So what happens, consequently, is I get a pair of corresponding angles. So I have to be able to start to recognize these special angle pairs in different settings. So we know corresponding angles are equal, so immediately I can set up here and say that 5x minus 5 equals 4x plus 10. Okay, and then I'm going to solve that equation. I add 5 to both sides, and we'll subtract 4x from both sides. So right away I have that x is equal to 15. So we know what we're probably going to have to do now. We need to find y. Well, since I know that x is 15, I can see I have a linear pair here. Those 2 angles add up to 180 degrees. So if I can find this angle, I have its supplement right next door to it. Okay, so that angle is 5x minus 15. 5x minus 5. 5 times 15 minus 5. So that's 75 minus 5 is 70. Okay, so we have this angle here is going to be 70. This angle here is its supplement, so that angle must be 110 degrees. So we'll solve that equation. 6y minus 4 equals 110. We're going to add 4 to both sides. So we have 6y equals 114, and then divide by 6. So we have y equals 19 for that solution. Okay, so let's take a look at this next one here. We have a 90-degree angle, and we have our parallel lines running this way. So what we have in each situation are same-side interior angles. Okay, so if this is 90 degrees, remember same-side interior angles are supplementary, so they have to add up to 180. Well, luckily this is 90, and then the supplement to 90 would also be 90. So the first equation that we can solve should be pretty simple. We have 3y plus 18 equals 90. Okay. Second one, not quite as easy. 15x plus 30, they're not equal to each other. But if I take 15x plus 30 plus 10x, they're supplements, so they ought to add to 180. Okay, 15x plus 30 plus 10x equals 180. So what do I have here now? 25 x plus 30 equals 180. We'll subtract 30 from both sides over there. So I have 25x equals 150, and then we divide by 25. So x equals 6. Now we come back over here and solve this one. We would subtract 18 from both sides. So I have 3y equals 72, and then divide both sides by 3. So we get y equals 24 there. Okay, so in the next couple of examples, I'm going to set the equations up, and I'll let you finish them off and solve from there. So let's take a look at what we have. Here I have same side interior expressions that both involve x, so I'm going to have to use those to solve x. Same thing over here, I'll have to use these angles to solve for y. Same side interiors are not equal to each other. They are supplementary, so we have to be careful about how this hashes out, right? I would have 11x plus 4 plus 5x. That should add up to 180. I'm going to let you solve that from there. Okay? Next we have 5y plus 5 plus 13y minus 5. Right? I add those two together, they're going to equal 180. So I want you to finish the algebra for those from here on your own. If you did that correctly, you would have 16x plus 4 equals 180. Subtract 4 from both sides. So 16x equals 1. So x equals 11. Then in solving for y, we have the 5 and negative 5 will combine and go away. 5y and 13y is 18y, so we just get y equals 10 here. Okay, so let's have a look at what they give us here. We have our parallel lines, and we have same side interior. So I know that this whole angle here and this whole angle here add up to 180 degrees, but that equation is going to give me x's and y's. I won't be able to solve it. But take a look at what we have here. I've got alternate interior angles. So I can start off with 3x equals 5x minus 20. That we ought to be able to solve for x. Once we do that, okay, we can plug that x value in up here. All right? Once I have that x value, I know that all three of these will add up to 180. So in other words, I would have 3x plus 2y plus 4y equals 180. Let me write it up here. More space. Okay, so just to reiterate, you've got to solve this equation first. Once you have this equation, once you have x, you can plug it in up here, right? 3 times whatever that value of x is, and you'll just have to solve for y in that equation. Give it a shot. Okay, so if you solve for x correctly, we would subtract 5x from both sides. I'd have negative 2x equals negative 20. Divide both sides by negative 2, x equals 10. So we take x equals 10, we plug it in up here to our other equation, 3 times 10, which will be 30, plus 6y equals 180, and we'll solve that. Okay, so I plug that x equals 10 in, subtract 30 from both sides, we get 6y equals 150, Divide by 6, and we get y equals 25. Okay, so down here I have 3 variables. I'm going to set this up into 3 parts. I kind of have to find the variables in a specific order. The first one I can find is 2y, because from my picture here I can see that 2y plus 106 is going to equal 180. Okay, so solve that first. After you solve that, you'll have y. Well, I can see here that I have corresponding angles, so x and y are equal to each other. I'm sorry, x equals 2y. But once you have y, you can plug it in over here and solve for x. Also, we can just look here, we have corresponding angles here and here. So this is also 4z plus 6. So 4z plus 6 is equal to 106. Okay, so go ahead and solve those 3 equations and let's see what you get. We should subtract 106 here from both sides. So I have 2y then equals 74. So we should have got y equals 37. Okay. Now if y equals 37, then x just equals 2 times that. So x should equal 74. And some of you might be saying, well, Mr. Dempsey, I could have figured that out just by looking at it, right? If this is 106, that's 74. They're supplementary. Well, that's fine too. Yeah, x, of course, would equal 180 minus 106. Okay? So I have x equals 74, and then finally we solve for z. So we would subtract 6 from both sides. So 4z is equal to 100. So we should have got that z is 25. So that would be your correct set of 3 solutions there. Okay, so now we have our last example, our last practice problem. I'll get it set up for you and you can finish it on your own. Again, we've got these 3 angles here all add up to 180 degrees. Well, 90 of that 180 is right here. So we could just get to this pretty quickly and just start off with the 2x plus that x. They have to add up to 90 degrees. I mean, you could say 2x plus 90 plus x equals 180, but why not just take the 90 away and know these other 2 must add up to 90, so we can start with that. Okay? Once you get x, well, that's going to be equal to 2y. They're alternate interior angles. So whatever you get for x, throw it in over here, and you will be able to solve for y just simply by dividing it by 2. Okay? And then finally, the last step, once we know what y is, we can take y and plug it in here. 2 times y plus z has to add up to 180 degrees. Okay, so solve for x, y, and z, and let's see what you get. So we should have gotten here 3x is 90. So x should just be 30. Okay, so if x is 30, what do we have here? 30 equals 2y. So that means that y is 15. And then if y is 15, we have 2y here, which would be 30, plus z equals 180. So we subtract 30 from both sides to solve that. And we have that z equals 150. Okay, so that's it for our notes for 3.2.